Hello, everybody. Let's see. I thought I would just do a whole bunch of Chapter 7 problems. Not sure how long this video is going to take. I might try and make it take about 20 minutes. But yeah, I'm just going to do as many of these as I can. These are all from the review exercises in Chapter 7. Well, except for the Check Your Understanding episode or ones. There's the rest of them. Good. Okay. Yeah. So here's a nice standard box problem. Okay. So first thing they're going to ask us for, what is the volume V of X? Well, yeah. What do we do to get volume? I do length times width times height. Right. So length. Whoops. Length, width, and height. And there you have it. So if we simplify, I'm going to get 49x cubed. So just combining the 7's and combining the x's, and there we have it. So v of x is 49x cubed. This is a power function with constant of proportionality 49. Our variable is x, and our power, p, is 3. That's how we go through that. Now, if we double the value of x, what happens to the volume? Well, so we have this property. If I have f of a times x, that's the same thing as a to the p times f of x. In other words, doubling x, so when a equals 2, what I'll have is 2 cubed times my original f of x, or 8 times 49x cubed. What's 8 times 49, you ask? I don't know. What's that going to be? 72, 7 up, 32, 30, 392. So in this box, I would have 392. Oh. Went a little too detailed for that. It says the volume is multiplied by, not the new expression is, but the volume is multiplied by 8. All right, that's that. Let's see. Okay. All right, so this is pick the power function. So let's see. First one, yep, that's k equals 6, p equals 1. That's power function. My variable is t, so I would write oh dear, direct here. This one too, k is going to be 7, and we got a t squared there, right? That implies that p is going to be 2 for this one. Cool. I think there might have been a hiccup in the video there. I hope everything looked okay for folks. I have to rewatch it later. Now this fella, not so much power function. All right, we have a constant plus a kx, or a kt to the p in this case, so not quite a power. Same thing here. In this one, we got k is 5, right? The constant hanging out in front of the variable. And the t to the minus 2, that means that p is negative 2. And so that negative right there, that makes this an inverse proportional. So that's how that one goes. Okay. Well, let's do one more of these, and then I'll start skipping around a little bit, trying to find better problems. So I might post this PDF, but, well, I might not. I'll show you guys a little bit. Well, you can open up the chapter in Wiley, right? And I'll just show you how to do that. Just to review, let's see. Wiley Plus. There's go Wiley Plus. All right, my session's no longer active. Just click again. Okay. So let me make sure I'm screen sharing with you guys here. Yeah, you don't want to look at my face while I'm doing this, do you? There we are. So yeah, I've pulled up the Wiley Plus website. I'm gonna go ahead and log in. Oh no, I don't remember my password. And that's how videos go. Oops. Okay, well, try one more time. All right, we're in. Okay, I'll have to splice that out of the video. Okay, so, yeah, okay, so here we are. We'll go to Student View, so it looks just like you guys. If you want more practice problems, well, go to Read, Study, and Practice. Pick your section like so. And wait a minute for it to populate. There it is. What I do is I jump straight here and just quiz yourself, right? You can look at the answer for most of these. So just pick them at random, run with them. It's all right here in the chapter review. And there's also these check your understanding problems. They're true false, but it can really help you test your understanding. Okay, so that's where I'm pulling these problems from. And so you can check them for yourself over there. Let me switch back over to the iPad here. Yeah, there it is. Okay. So that's where you can get your practice problems. Okay, so let's take another one here. So we've got a bathtub, 16 gallons of water. We need to construct a function to describe the water volume in gallons per minute if it's filling at a rate of 4 gallons per minute. Okay, so the volume, so we want an expression for volume in terms of T. Well, if it's going 4 gallons per minute, and I'm multiplying it by T in minutes, I mean, the unit analysis certainly works out, right? So I believe what we need here is that we have a power function with P equal to 1, K is equal to 4 gallons per minute, and our power function looks like 4T to the first power. Boom. What would be a reasonable domain for this function? Well, we start, and I'm going to start talking about the range, and it's going to feel confusing for a second, but let me get through this, right? We start at 0 gallons, and we go to 16 gallons, right? That corresponds to 0 minutes, and then how long would it take us to fill the tub? 4 minutes, right? 4 times 4 is 16. So this is my range, and this is my domain. There we go. Alrighty. Yeah, look, it's even an option. Let's see, what is this? Graph VF of t by hand. Okay. Well, it's a line through the origin with a slope of 4. Right? Does this direct or represent direct proportionality? Yes, for a couple of reasons. The function is of the form kt to the p. And also, it passes through the origin. And that's the difference between linear functions that are also power functions and linear functions that are not also power functions is that difference. Does it pass through the origin? Is b equal to 0? There's another way to say that. Okay, so part B here says if we fill the tub to the brim, so what if it starts draining water at a rate of 0.5 gallons per minute? Not much different, right? We have a K is now 0.5. Our P is still 1. And so this one is going to look like 0.5 gallons per minute times T in minutes. What would be a reasonable domain for this? Well, we're going to stop when we're done draining the water, right? So the question really is, for what T, oops, 0.5 times T, when does that, when does that equal 16, right? When we're done pouring out 16 gallons, we'll be done pouring, or be done draining. Okay. Well, dividing by half is the same as doubling, so I believe we're going to get 32 minutes out of this. Hey, look, it's even an option. Excuse me. Okay. So let's see here. Excuse me. So let's go over this one. So we have that W is proportional to both S squared, the wind speed, and A, the area swept out by the turbine blades. So what do we call this? This would be jointly proportional. And all right, let's go for it. Calculate the area in square feet swept out by the wind turbine blades if the rotator radius is 40 feet. The rotator radius, so we have A. So A is going to be what? Pi r squared? Pi times 40 feet squared. Okay. Well, I just need to know what pi times 40 feet or 40 squared is, right? That's easy. I can even type pi and do it for me. Isn't that cool? Times 40, hit the squared button there. All right, 5026.55. 5026. So to the nearest integer, that would be 5027.55. Yeah, there we go. Okay. And I guess the key there is to remember that if, I've got like a turbine here, the area swept out is going to be a circle with a radius 40 feet there. Okay. Well, geez, that's all they wanted us to know about that, I guess. It's annoying to give us so information in just one question. Okay, whatever. All right. Try this frequency problem. I'm gonna skip it. Yeah. Go ahead and skip it. I'm gonna skip this one too. Okay, let's try this one. In Nashua, New Hampshire, we rent an outdoor skiing facility, $300 every half hour. What is the cost per person, PN, if there are friends sharing the experience? Well, if it costs $300 and I have N people, then that would be the dollars per person, right? Cool. So what we have here, inversely proportional function. K is 300. P is -1. And the variable we're using is N. So this is a power function, P of N, where it's $300. They already got the dollar sign there. Times N to the -1. There we go. So if I was doing this with 2 people, what would I get there? 150. If I was doing it with 5 people, well, let's see, 300 5. And same thing as 30 times 0.5. Oh, but I double things if I'm dividing by half, so this should be 60. I wonder if we get that. 5 times 6, 0, 0, add a 0, 0, 30. Have I screwed it up somehow? Oh, yeah, I have. That should be a 6. This would be a 6. That would be a 60. All right. 0, 0. Ah, too many zeros here. Yeah, stack multiplication. Betraying me. 5 times 6 is 30, not 300. Add that up, I got 300. You guys remember that from grade school, right? Yeah, we don't need no stinking calculator. It'd be 60 bucks per person. What is the trade-off between number of people and cost per person? What is the trade-off between number of people and cost per person? If n goes up, cost per person goes down, right? I'm not sure exactly what format. You'd have to look at the drop-down menu for that, but that's the idea there. Hey, look, a little formatting errors there. We'll just skip those, shall we? When you look at these on Wiley or look at the answers, you'll get something besides a string of code. So I'll just go over that. We'll just skip right over. There's a gravitational law. Or no, that's a light intensity law. Interesting that gravitation and light follow the same inversely proportional rule. Yeah, so we have the intensity of light as a function of the distance from the light source is the candle power divided by the distance squared. Just implemented some function notation there, nothing else. So let's think. If my candle power, so if my D is 1, so it's saying let's compare D equal 1 to D equal 3. Here's the power. There's the candle power. So that's the constant P equals 70 in this case. So what is I of 1? That's going to be 70 divided by distance 1 squared, or just 70. What's I of 3? I'll just plug in 3 for D. 70 divided by 9, so 3 squared. Oh, I don't know what that is. Let's look here. Oh, 7.78. All right, that's how that one goes, guys. Cool. Yeah, and there's another candle power to practice with right there. People did pretty well. The quizzes that I have back, where I talked about the range and domain and concavity of power functions, people are doing pretty well so far. So we'll go through it. Why not? Which of the graphs depict power functions with a negative exponent and hence inverse proportionality? Okay. Well, this one looks like x squared, right? So that one's no go. Now let's think. This has the kind of shape we're looking for an inversely proportional, but there's a problem. It's not passing the origin, but it is hitting x equals 0. And we know that power functions that are inversely proportional kind of skip around 0, as we see here. So it's going to be B and D that are true power functions here. So I would write B and D there. So let's think. The domain of one function is, well, look, this one's all real numbers, and this one's all real numbers. Well, except we can't plug 0 in. So all non-zero real numbers. All non-zero real numbers for both of those, for both B and D. What is the range? Well, this one, let's see here. This one's going to be, we'll do it for B first. This will be for B. Well, I don't get negative numbers, and I get pretty darn close to 0. So I'd rate this 0 to infinity, round brackets on both sides. And what about this one? This one's going to be negative infinity to 0, right? Negative infinity all the way to 0. And so union with 0 to positive infinity. Yep. There's how that one does. Okay. Describe any apparent symmetries and asymmetries. So here's what I'm going to do for this. If I fold this, so if I fold this like this, so make those corners match, and like this, make these corners match, I would successfully have flipped this graph. So I'd flipped it this way, right? Then I'm going to flip it that way, fold it, fold, if you will. This curve would line up nicely with this curve if I did that. That is called origin symmetry. And it's different from what we see in these two examples. Let me even circle it in a different color. Ooh, whoa, what happened there? What happened there? What happened there? There we go. Those two have a y-axis symmetry. I think symmetry actually has 2 m's. Okay, so there's that cleared up. Oh, I don't know how much more I should go through here. Hey, let's do some true or falses. So here's one here. If f equals km to the negative 3, where k is a non-zero constant, f is directly proportional to m. That's a false, guys. That's a false because p is negative. Because p is less than 0, i.e. negative. That's what you got there, guys. Yep. Okay. So here we have 2 decreasing power functions. So 2 inversely proportional functions, right? And for these functions, q is less than p. And we're supposed to say true or false. If q is really less than p, then g of x will increase, what am I trying to say? If q is less than p, then g will decrease less than f does, right? This goes back to our example. If I have like x cubed versus x to the 5th, this guy is the faster decrease. So let's think here. So p is less, if p is less than, if q is less than p, then f will decrease less quickly g will decrease less quickly than f does. Let's look here. Here's my g. It's below my f, right? that means it's decreasing faster than my f does. Well, that is no go, guys. False. All right. So just cherry picking these. Ooh, all linear functions are power functions. This feels like something I've put on a quiz before. Not this year, but feels like something I've put on a quiz. All linear functions are power functions. Yeah. Except when e does not equal 0. Yep. If it has a y-intercept, it's not a true power function. It is not truly directly proportional. Okay. Here's another one. So if I got a power function where p is, so I've got a positive integer for p, right? So I'm a directly proportional, p is positive, those are the same things, and it's an integer, so whole number, then the range, the outputs, are always 0 to infinity. Well, sure. Okay. Okay. But what about this one? Not so much, right? Negative range, right? So that's a falsie. Guys, I think I'm going to leave it there. I don't know how long this video is, but I hope I've done a lot of examples. Hope that helped you out a little bit. Y'all have a wonderful break, and I'll catch you guys for the test. Probably not the Monday after break, but the Tuesday.